Okay, so what I have here are some glass beads that we ran. These are actually some controls that we have. You can tell it's pretty monomodal, pretty tight distribution. Only ran about 2,800 particles, and it took about a total of a few, I don't know, about 2 minutes, I think, at a pretty low obscuration level. This is what I would consider a very low obscuration level. Just to give you an idea of what types of things we can look at with respect to the particle insight and looking at how to differentiate between some of the particles. The first thing I normally do is I look at the thumbnails. Looking at the thumbnails, we go ahead and we open the post-run processing, and then we just go ahead and click on thumbnails. Once we click on thumbnails, we can actually go through the different thumbnails, and we'll see that I did this on purpose, where we can actually capture some particles that happen to be in the same place at the same time. But we also see that there are some particles as we scroll through that were kind of elongated as well. There were some long ones, short ones. There was also a few in here that I remember seeing that were a bit dark in the center, and then some of them were kind of looking like a football. So here's some of the longer ones that are elongated. These are some of the snowman ones, which are kind of strange. There are also some long ones, and then there are also some dark ones. So, for example, let's say we wanted to determine the difference between a long one and actually a dark and a light one. You know, we can actually determine that by looking at this value, which I selected to be opacity. I can tell that the particles that are dark have somewhere about 0.7 opacity, and the particles that are light have about a 0.6 opacity. So if we want to find out at the end of an analysis how many of these opaque particles were in the distribution compared to the non-opaque particles, we can then go over to the opacity measure and then look at those differences. So by opening the opacity in a large window, we can actually go in and we can start scrolling through and looking at what area of the distribution we just want to look at. So in this case, what I did is I scrolled in all the way from 0 to 0.7, and 0 to 0.7 are the lighter particles. The darker particles are above a 0.7. When I go ahead and hit the statistics button, I can see the exact number of particles that I found from 0 to 0.7, which is 2,815, and that represents 90.81% of the distribution. And I can do the inverse. This can be done for opacity, it can be done for size, it could be done for circularity, it could be done for all at the same time. You can actually look at how many particles were long and opaque, or were not so smooth and very light. So you can look at multiple factors. Another thing that we do is we can actually look at the scatter plot of the different graphs, and to do that I'll go back to post-run processing, and now I'm here at post-run processing, and then what I will do is I'll do a correlation plot of, let's say, how I don't know, how light they were, or let's say by size, and by, let's say, size and opacity. So here I selected size and opacity, and then I'll go ahead and create the correlation plot. So this really doesn't tell me a whole lot, but it basically says that looking at the different size, they were all mostly between about 40 some microns in size. There were some smaller particles, and I can tell that the opaque particles are all tend to be above a 0.7, all in the same region. So this really doesn't tell me a whole lot, but maybe by circularity it would tell me something. So let's go ahead and change this and look at it by circularity. Anyways, we won't go into too much details of the correlation plots, but I hope this really helped in basically letting you understand that the particle insight is very versatile. We can actually look at what percentage of particles with any kind of parameters are within the distribution, and we can actually look at just those particles. In this case, I looked at just one area of a correlation plot, and I recalculated all the statistics based on those criteria of interest. So, an incredible amount of information you can get from the software. So I hope this helps. Thank you very much.